Okay, good morning. Today we want to continue our discussion on trigonometry. So I need to correct the spelling here. Where is this clean? So trigonometrical identities. Of course, this is not in lesson actually, because even when you have sine squared x plus cosine squared x is equal to 1, that is an identity, yes? Trigonometry, again it's wrong, yes? Trigonometrical, yes. So that's not a new lesson actually, because you need to use all your knowledge in trigonometry to be able to show that two trigonometrical expressions are equal. Yes? That's it. So, and of course you need to use algebra, whatever you learn, for example, conjugate pattern, or I don't know, squaring pattern, or whatever you have learned in algebra, combine it with what you have learned in trigonometry to be able to show that two trigonometrical expressions are equal. Yes? So probably the simplest possible trigonometrical identity is just, for example, this one. Sine squared of x plus cosine squared of x is equal to 1. So let me just review this. When I say that is an identity, it means that regardless of the value that I choose for x, if I calculate the left-hand side, it matches the right-hand side. That is the meaning of an identity. Later, we will have a very important discussion, and that's called solving trigonometric equations. Okay, that's a different story. For example, in those contexts, I might write something like this. Equals to 1. Of course, is this an identity? So for example, you immediately realize this is not an identity. Why? For example, if I choose, of course here if I choose x equals to 0, then sine of 0 is 0, cosine of 0 is 1. When I add them, it becomes 1. But for example, if I choose x to be 30 degrees, sine of 30 degrees is 1/2. And this one is a square root of 3 over 2. When I add them, it does not become 1. So this is not an identity. This does not happen here. Whatever you choose for x, the left-hand side is always equal to the right-hand side. We call it an identity. But here, there are some x's, so that makes this equality true. But for other x's, this equality is false. And then, in this case, I might later ask you, find all values for x, so that turns this equality into a true equality. Or, in short, I ask you solve this equation. So I just want you to understand the difference between, here I cannot ask you solve this identity. I have to say show this or prove this identity. Here I cannot ask you to show this equation. I have to ask you solve this equation. Yes? So that would be a very, very important lesson of this chapter, which will come later. But here we want to talk about trigonometrical identities, which is also very, very important to know. So at least I hope that you understand the difference, because they look like the same. So here you have some variable x, you have equality, you have here variable x, you have some equality. Okay. Of course, I can ask you solve this equation, then what would be the answer? If I give you this and I ask you solve this equation, what would be your answer? Yes?
X belongs to the set of real numbers.
Real numbers. Every real number is a solution. So in principle, you can say identity is an equation for which every x works. Yes? That's also one way to look at an identity. Okay, but usually I use the word show or prove these identities. So that's one identity. For example, let me just give, there is no lesson, we have to practice to learn, okay? So example, prove the following identities. So this I would write whenever they make sense. So by this sentence, which we usually don't write it down, but we always mean that. For example, if in your identity tangents, let me start one by one, okay? I will describe that, what do I mean, even though in the exam I will not write this sentence anymore, but this is always what I mean. So number one, we want to show that cosine to the 4x minus sine to the 4, so this is also 4x, is equal to, let me think a little bit, 1 minus 2 sine squared x. So for example, we want to show this. So I don't know what we can do. For example, usually it's always better to start from one side to try to manipulate it a little bit using legal mathematical ways, and then reach to the other side. Of course, you can work on this one, simplify it some steps, and then simplify this and compare the results again. Yeah, if that problem is very, very hard, that's also an option. But if it's not very hard, I myself prefer to start from one side and reach to the other side. And always I recommend you to start from the side which is more involved, because then you have a lot of more options to actually simplify this. If you want to start from a simple one, then this is a little bit against human brain. We have to make a mess, yes? We want to start from a simple thing and make it bigger. So this is probably a little bit against our intuition. So here I would prefer by this explanation. So please listen to these explanations, because there is nothing that I can teach you unless giving you my own transfer my own experience to you. Okay. So I start from the left hand side because I find it more involved because of powers of 4 or something like that. Okay. So tell me what to do. So this is extremely important to have algebraic identities somewhere in the back of your head. I have another YouTube channel. There are some nice lectures about this algebraic identities. I will put the link for you. 1 or 2 of them is enough to listen if you have forgotten those things. Okay, so if I want to do that, do you recognize any pattern on the left hand side? Yes? The conjugate pattern. So I factorize it, yes? So this becomes cosine squared x minus sine squared x multiplied by cosine squared x plus sine squared x. Yes? But I can do better here, because now this is something that I learned in trigonometry. In trigonometry, that is 1. Okay, so this 1 times this 1 is exactly this expression. So it's very nice by itself. It doesn't matter if you put powers of 4 or powers of 2, they are the same. Okay, so that's in itself interesting. But then it is not finished yet because I haven't reached to the right hand side. But then this is the way that you need to think. You can say to yourself that, okay, I have a combination of sine and cosine here. But here on the right hand side, I do not have any cosines. So this kind of arguments you need to learn to do it for yourself. So it means that I want to get rid of this cosine squared somehow in favor of sine squared. If you think in that way, there is a nice relation between that, yes? So we know that cosine squared is a famous combination. I told you it's 1 minus what? Sine squared. So what you can do, you can transfer it here. So it becomes 1 minus sine squared x minus sine squared x. Is that understandable? So I reached to this point. So the starting point was probably, if you are a little bit experienced, you immediately realize that it might be the conjugate pattern. I did the conjugate pattern, and then I realized that there is a famous identity appearing in this problem. So I use this fact that this is equal to 1, and 1 times this expression is that one. I have been able to simplify it. At least instead of powers of 4, now I have powers of 2. And of course, if this question has 2 points, so far you receive 1 point. Yes. And then you want to continue. You see that, okay, the expression that I got is not exactly what I want, but how should I go there? One logic behind that is that I have to get rid of cosine, because on the right hand side I do not have any cosine, but instead I have sine squared. So this motivates you to get rid of cosine in favor of sine squared. And if you think in this way, and if you have done your homework right, then immediately this idea comes to your mind, so that you can replace cosine squared with 1 minus sine squared, and then you are done. Yes, because minus sine squared is minus 2 sine squared. And then it becomes 1 minus 2 sine squared, and that becomes equal to the right hand side. And here you are done. Yes? So you see there is no new lesson actually, but you need to practice more or less a lot on this topic. Okay? But let me just talk about wherever or whenever they make sense. Here it always makes sense. Yes, I do not have any problems with sine and cosine. They are always defined. Yes? Okay, now what do I mean by this sentence? Do you remember, I also recommended you to remember this formula, even though it is not in the formula sheet. Let me just repeat it again. So 1 plus tangent squared of x is equal to 1 over cosine squared of x. This I told you that remember this formula, but let me just use it as an excuse to explain this. For example, this is always true for all choices of x, but I cannot say that this is always true because there are some gaps there. For example, if I take x to be 90 degrees, cosine of 90 degrees is 0 and 1 over 0 is not defined. So this, whenever they make sense, it means that if these anomalies does not happen, then this is an identity. Yes? So in principle, if I want to be very precise, I should say that prove this equality whenever cosine x is not equal to 0. But this usually I do not write in the exam, but the precise way of expressing that it is to say that prove this equality whenever cosine x is not equal to 0. Okay, but I think this is so simple, so let me start immediately solving it. I have already done that. So I will start from the left-hand side, and then I would write 1. Instead of tangent, I see tangent is involved here. I do not have any tangents, so this is immediately clear to get rid of tangent in favor of sine and cosine probably. And then you learn that you can put these powers immediately on top. And I have already described why you can put it here. In principle, it should be like this. But a fraction to power 2 is this one to power 2 divided by this one. You really don't need to write these details. Instead of 1, you can write cosine squared x divided by cosine squared x because of having the same denominators. And then this is very, very simple actually. Okay, so then what happens? So I write cosine squared x and then I add them. So it becomes cosine squared x plus sine squared x. But again, you see this appears, it becomes 1 over cosine squared x, and this becomes equal to the right hand side. Yes? Okay, so that's it. So let us start now solving a little bit more fun problems. Okay, so number 3. Let me see. Okay, so that's a good exercise to start. So sine x divided by 1 plus cosine x, and then you have 1 the other way around. 1 plus cosine x divided by sine x is equal to 2 over sine x. So again, this is not always true. If I am unlucky and the one denominator vanishes, then this doesn't make sense. But when I say prove it, it means that you are on the safe side. Assume that this is not 0, this is not 0, and then show that this is always the case. I don't know, do you want me to solve this one as well? Let me solve this one as well, and then I give you some more exercises that you can think about. So it's clear that I have to go from the left-hand side to the right-hand side because it is more involved. So I'll start from the left-hand side. So what can I do? I should take the common denominator. Of course, the common denominator, I want you to teach to be fast, you know. I myself prefer to do it in this way. So what is the common denominator between this and that? Here is the product, yes? The common denominator is not always, the product will always work, but it is not always efficient. So when I say common denominator, I need to emphasize, for us, it is always better to have the least common denominator. So it means an expression which is simultaneously divisible by this and that, but it is the smallest possible one. Yes, in its lowest term. So it means that if I want to have something which is divisible by that and this, these two should appear as factors in that least common denominator. So in this case, I have to multiply them, yes? But multiply them formally. What do I mean? I mean just write them as a product, not in action. Do not multiply it in action. Just keep it like that. Is that clear? So that would play the role of the common denominator. Now think in this way. You take this one in your head and then divide it by the denominator of the first one. What is that? This is gone. What is left for me is sine. And you multiply this factor to its own numerator. You have already one sign there. Another sign will be multiplied there. It becomes what? Sine squared. Let me just repeat it again here. I compare this least common denominator with the denominator of the second fraction. I divide this in my head by that. What is left is this factor. I have to multiply this factor into the numerator of that second fraction, which coincidentally is exactly the same expression. Yes? This numerator is exactly this. So then what happens? I have to multiply this by the numerator. And I have an addition here. So it becomes 1 plus cosine squared, cosine x, totally squared. Okay, I just want to wait a little bit for you. Is that understandable for everyone? No questions? Okay, the rest of it, my really strict recommendation, do not multiply the denominator. Just keep it in that way, but try to simplify as much as you can in the numerator. Okay, so it means that if every step you have to copy and paste the denominator until the end of the problem. So what you do, I just copy and paste this, but of course I prefer to write it on, it doesn't matter. Let me just, don't confuse you. Okay, so here, you need to have always an I on the right hand side. So I don't want to get rid of sine, because I have sine there, I need it. But this cosine is a problem here. But I need to get rid of cosine, but there is not a very good way of getting rid of cosine. I can get rid of cosine squares, not cosines. If I want to get rid of cosine, if I want to use this, I'm making life harder for myself because I have to take square root and then I have to put plus and minus. So it doesn't make, it's not making the problem simpler. So don't go for it, okay? So then there is only one option left. If I don't want to use this immediately, the only thing comes to mind is a squaring pattern. Yes, so I square. So I keep this the first term without touching it. And then I would say that the first one to the 2 plus 2 times the first one times the second one. And then plus the second one to the 2. Yes? As I told you, do not touch the denominator at all. So just keep it like that. Is there something that I can do in the numerator? Yes or no? Yes, what can I do, for example? Then you see that this famous combination appears here. Yes? Sine squared x plus cosine squared x gives me 1, and there is an extra 1 in this numerator, so it becomes 2. So then it becomes 2 plus 2 cosine x. So at least we simplified a lot so far, but it is not finished yet because I haven't reached to the right hand side. But what can I do now? I can pull a 2 out in the numerator, so I can just factor 2 out. It becomes 1 plus cosine x, and what I have is 1 plus cosine x sine x. Now, can I simplify this by that? This is also something I want to ask you. If I ask you to read this in English, no, let me ask you in this way. What is this structure? You would say this is a product between 2 and 1 plus x. So you read it as a product. If I just ask you to read this, you would say this is a sum. But if I ask you to read this, this is a product. Yes? And is this one a sum or a product? It's also a product. So if you have products, then you can simplify factors. Okay? So this is a product. What are the factors? 2 and 1 plus x as a whole. And what are the factors here? 1 plus x and sine x. And then you see that immediately when I was reading it in English, I realized that this is a common factor. So then I can simplify that. And then what happens is 2 over sine x. And is it the right hand side? Yes. So it means that I was able to show this. So these kind of calculations you need to practice to learn. That's it. There is no new lesson in this. There is no new concept, no new lesson. Understandable? Okay. So, I don't know. Might be I can give you another one. Wait for you to see how it goes. Yes? Okay. So let me see which one, because unfortunately all the books contain cotangent, but I want to avoid cotangent, so because cotangent is not in your book. But of course I told you cotangent is nothing except it's 1 over tangent. Yes, that's not a big deal, but let me try to avoid that as much as I can. Okay, so prove this one. So this is number 4. 1 plus sine, let me change the letters. For example, let me change to theta this time. Divided by 1 minus sine theta minus 1 minus sine theta divided by 1 plus sine theta. It's equal to 2 tangent of theta divided by, I would say, cosine theta, yes. Let me double check. No, this is not 2, this is 4. Okay? So I can wait for you a little bit so that you can start solving this yourself. Okay, so if you solve that one, you continue solving these. And then I ask you if you are volunteer to come and solve it here. Otherwise, I solve it myself. Could you solve the first one?
Yes.
Is any volunteer to come here and solve? But you need to use the traditional method of chalk and chalkboard. Do you want to come? First, for the first. Yeah, number 4, yes. Yes, so let me put you in reserve. Anyone from the people who haven't come here, if you really have the solution and you are more or less 70% confident about your solution, you need to come here, okay? No one? You want to come? No? What was your name? Yes? Kiev. Why don't you want? Okay. Anyone else? Okay, so if you want, we can come. But are you comfortable with writing chalks with chalks? You can test that. Yeah. Yeah. Please continue solving, and then next person come and solve, because there is no lesson. You need to practice here. This is not something that I can do much. You need to practice to be comfortable with this. And I think it's better to take the white chalk. I think it would be.
I started from the left hand side.
Yes? Yeah, please listen. Yeah, which is a very natural starting point, yes?
And then I wrote this part
Yes?
on the same fraction line.
Yes, yes. So what she means actually, I would prefer you write the denominator first for pedagogical reason, yes? So you are taking a common denominator, so what would be the common denominator? Again, here it's a coincidence. It's the product of the two, yes? Don't think, usually in trigonometry it is the case that you multiply them, but this is not always the case. Thank you.
That, and then the numerator becomes it becomes this.
Yes, is that understandable for everyone? Yeah, please let me know. That is your own responsibility. If you're silent and don't understand something, that is on you, not you, okay?
And then I realized that this is the numerator.
Yes, denominator.
The denominator is conjugate pattern.
Pattern.
So I write it like this.
Yes.
Because 1 squared is just 1.
Yes.
And I multiply the numerator.
Yes. Very nice. So she is actually using this squaring rule to square them. The first one to the 2 times the first one times the second one to the 2. And she respected that when you have a negative sign, it is better to put this pair of brackets, or if you want to do it mentally, you need to know that this negative sign goes for all of them. Yes? Yes.
But then I just multiply the negative sign in, so it becomes minus 1, and this becomes a plus, and this becomes a minus.
Yes. So now she removed the pair of brackets and applied that negative sign into all those terms. Yes.
Yes, and then plus 1 and minus 1 will cancel.
Yes.
And minus 2, sine 2 theta and plus also cancels.
Yes.
And then we have 2 sin theta here and 2 sin theta here.
Yes.
And then I chose to get rid of sine in
Yes. Yes.
here, so I put it as
Yes.
and then I remove
The pair of brackets is becomes positive.
and these cancel.
Okay, so Dennis, if you write an exam just immediately cosine squared, I accept that because I told you that 1 minus sine squared, you see it's still on the board on top. 1 minus sine squared is cosine squared. You don't need to explain all these details. Of course, you are always welcome to explain, but these details you don't need to because otherwise it will tie your hands actually all the time. Yes. So here, no, it's not finished yet. Be careful.
Sorry.
For tan, okay.
Yes. Sorry. Then you just use. Then sine is just tan times cosine.
Yes. Yes.
So I did.
Yes.
And then one of these cosine
Yes.
can be simplified with
Yes, because
this
they are
one.
factors. Yes. And then that is exactly the right answer. Yeah, thank you very much. So what Dylan actually supposed, you can also use conjugate rule here instead of expanding because that is also, let me see if it works here. So if I have this pattern involved, something to power 2 minus another thing to power 2, that's also a conjugate pattern. So Dennis in her solution used a squaring pattern, expanded that, but can you, if I have this situation, you can also write this. Yes? This is also possible. Okay? And then here, let us see how this will go. 1 plus sine squared, let me see if I can. Yes, that's more reasonable. So here you have that expression. I'm just showing you another way for the numerator. So I would write 1 plus, let us see if it helps or not. Minus 1 minus sine theta multiplied by 1 plus sine theta plus 1 minus sine theta. So this is actually Dylan proposed. So one way to look at that problem is the way then it's actually solved by expansion. But this is also working, even though it seems long. But if you do some of these calculations in your head, it is not that long, it's probably simple. Why? Is that understandable that I can write the numerator something like this? I am giving the role of this square to the first one and giving the role of that circle to the second one. And I am using this identity. Is that understandable? Now let us do some head calculations, yes? This minus sign goes into, it becomes -1, cancel this positive 1. This becomes positive sign, it is 2 sine. Then it becomes 2 sine squared, you know? So 2 sine theta, multiply. What happens here? Sine and sine are gone, 1 and 1 is 2, and then you multiply it by 2, it becomes 4. So that would be the numerator. So that also works, yes? Another thing that I wanted to say might be, instead of doing this in this way, Dennis actually nicely wrote sine theta, because she was thinking that, okay, on the right-hand side, I have tan and cosine involved. So it means that I have to get rid of sine in favor of those. Then probably, if you think in this way, this comes automatically. How can I get rid of sine and write something in terms of tangent and cosine? Cosine times tangent is a sine. Yes, is that understandable? And this is gone. You might write it in this way. For example, you can write it in this way. 4. You can write sine theta. You have 2 cosine thetas. Give one of them to sine and write it in this way. That's also possible. Yes? But then in that case, this becomes tangent times 4, it goes to the numerator, you also get the answer. So all of these things you have freedom. All of them are actually legitimate to do. Any questions? Okay, Dennis, how was the experience? Were I in shock? Was it good? Yeah, it sounds very nice, yes? It's like melody. Okay, now anyone else to solve the other one? Could anyone solve the second one? Second one on the board, number 5. So which side do you prefer to start with? The right hand side, because the right hand side is more involved. If you want to start from the left hand side in this one, it is, of course it is doable if you write it from the left, from the right to the left, and then after it is finished, write the other way around, it would be that one, yes? But this is hard to understand. I myself prefer to start from the right hand side and go to the left hand side. No one could solve it, you mean? You could? You want to come here? Yes, please. I don't know. You can start from here and then let me clean this part and then the rest of it you go here, okay? Let me also get this tight. Yes, please.
Yes. So start with the right hand side.
Yes.
And then instead of tan squared x, I wrote sin squared of x divided by cos squared x.
Thank you very much. Okay, be careful because here we have x and y. Okay,
Oh.
that's correct. That's correct. Yes. Yes.
Yes, okay.
No one get confused about those. Yes.
Then instead of
It's a
writing...
good idea. Go to the whiteboard.
Yeah,
Yes.
I think so.
So I think I should do this one for you guys. Just move it up. Then we will bring it down. Then people can see that, and you yourself can see. Yes.
Yes, okay, so instead of writing 1, I wrote 1 divided by cos squared x divided by cos squared
Yes.
x.
Yes. Very good.
And then it's a common denominator, so
Yes.
and then this is 1,
Yes.
so 1 divided by 1 divided by. And this is just cos squared x minus cos squared y.
Yes, because 1 over anything is that thing, yes? 1 over a number. Yes.
And then cos squared x can be written as.
Now you show the problem itself by just moving this board up a little bit. So now Paul sees that, if of course it is correct, but this is not what is demanded in the problem. In the problem, if you raise it a little bit higher, because I want to show number 5. In number 5, you see on the left-hand side, you have combination of sine squares. But what Carl achieved so far is a combination of cosine squares. And then automatically the old trick comes into the game. Yes, we have to get rid of cosines in favor of sines. Thank you.
Yes. And then this one cancels with this one.
Yes.
So yeah, this is just.
I write the positive one first. Yes.
Yeah. Well,
No, left hand side.
oh yeah.
Yeah. Yes, very, very good. Thank you. Thank you very much. I really don't have something to add, so I think, yes. But let me teach you something. If you care about to do something fast, yes, let me ask you something. For example, if you want to calculate this fraction, I don't know, for example, yes, of course you can take the common denominator. This is the method actually Carl used. So he actually calculated this addition, calculated, for example, this subtraction, and then you divide. That's also working, yes? But I myself prefer to get rid of all fractions in one go, okay? And then I realize that 2, 3, 2, 3, the common denominator is 6. So I multiply everything by 6. If I multiply everything by 6, this becomes 3, plus this becomes 2, this becomes 3, this becomes 2. And then it is very easy to see that the answer is 5. Yes, because 3 plus 2 is 5, and 3 minus 2 is 1, and the answer is 5. It's much more quick. But the reason that this method is work is because I have done this Carl method a lot of times, so I know that this will work, okay? Now, this is so it's 100% correct and very, very nice. But for example, let us just go back here. So if I wanted to do it myself, I want you to be fast. Yes? Of course, you don't need to be in hurry. But if I want to do it myself, so what do you do here? I have a fraction, a partial fraction again. So I get rid of fraction how? These partial fractions, I mean. I want to get rid of partial fractions here. I multiply everything by cosine squared. Yes? So what happens? The numerator becomes cosine squared. Yes? The denominator becomes cosine squared. And then this becomes the cosine squared that I am multiplying will cancel this cosine squared. So what is left is plus sine squared. Yes? And then of course you can also do it in your head. This is 1. So if you just multiply it by cosine squared, of course for the exam don't ignore those steps. This is the best way to write in the exam. But if you want to do it fast, you multiply by cosine squared, it becomes cosine squared, and the famous combination appears here. So it should be a matter of seconds to understand the whole combination is nothing except cosine squared x. Yes? So this is just cosine squared x, as simple as that. But in the exam, write it in that way, okay? But here, what is the answer to this if you do the same process? It becomes cosine squared of y. So that's it. So this is the one, some multiple choice questions in other entrance universities around the world. They do it in 90 seconds. They learn these things. Do not write like that. But now, of course, the good point about this is that your understanding might be higher. I don't know if they understand why this is correct or not. But when you write it in this way, you really understand why it's correct. But if you want to do it faster, you can just do it like that. This is very, by the way, this is also reasonable. Because if I have a fraction, I can always rescale my fraction by any number that I like. So I will rescale it by a number so that I can get rid of these fractions. You see? So calculating this immediately under one, I don't know, 1 or 2 seconds gives you 5. And that is really worthy to learn. Okay? Any questions? Yes, thank you very much. This is very, very nice. Okay. Anyone with the next question? We have time. Number 6 and number 7 are still left. If you want to think, I can pause the recording now. Should I, or we have a volunteer now? Okay, I will pause the video.
Should I do the whiteboard?
Yes, you can do it on whiteboard. I think it's easier. Yeah, and then let me raise this one as much as we can so that everyone can see that. Yes. And by the way, I forgot to say that you will be on YouTube. No problems? Yes. And the same for you, Ruben, yes?
Yeah. Okay, so I'll start with the left-hand side.
Yes.
And the tan b here can be written as sine
Yes.
b over cosine b.
Actually, here what Ruben did, I do the same, because you don't need to copy and paste the left hand side again. Yes, left hand side is in the question paper. Everyone can see that. So if you want to write something, be lazy. Okay, at least do something. You don't need to copy and paste the whole thing to start. It's in the page. Everything is clear there. Yes, thank you.
So I can write sine over b as sine
Yes.
over 1.
Yes.
And then to find the common denominator, I multiply these.
Yes.
So this becomes and that is just cosine of b. So,
Yes.
but then I have to multiply these two as well.
Yes. Yes.
So sine of b minus sine of b times cosine of b,
Yes.
and divided by cosine of b. Sorry, I lost.
No, let me see. So you got the solution.
Yeah. So I'm here right now.
Yes.
I don't know what I did there.
No, you factor some later out.
All right, yeah.
Yes. Yeah, you did it correct there.
So here I factor sine of b out,
Yes.
so it becomes sine of b times 1 minus cosine of b.
Yes. So he has chosen to factorize the numerator of the second fraction by pulling sign b out. Yes.
And
Oh, may I see again? No
yeah,
problem,
I don't
because that's
remember what I
correct.
did. So here.
No, you did it correctly. So you probably you see, this is a multiplication
Alright,
between them.
Yeah.
So you have written sine beta and then multiply. Very good, very good. Yeah, you have done everything there. And then
this is the conjugate method.
no, one thing is left. Just look at your notes because it was correct in your notes.
Oh, right.
Yes.
Yeah.
So yeah, your notes are completely correct. Just follow them. Yes. Now it's correct.
So now this is the conjugate pattern.
Pattern. Yes. Very good. Okay, 1 minus cosine squared beta is the famous combination is sine squared beta.
Yeah. So
Yes. Very good.
and then I can write that as
Yes.
over sine 3b
Yes.
times cosine.
Exactly. Exactly.
And then this sine to the power 3 can be written as sine b
Don't
times.
do that. Just change the numerator. Oh, that's also correct. But sine beta
Oh, right,
times
yeah.
sine squared becomes sine cubed. That is better, of course, than what you said. That's also correct.
And then
And finally, this is
I can-
yes, very very good. Thank you. And that's equal to the right hand side.
Yeah.
Thank you very much. So, yeah, that is a very nice way. Yes, it was actually a hard problem, and you managed to do that. Okay. Any questions here? But let me present my own way of doing that. Okay, so because I want you to learn these things. Not for the exam, by the way. This is a better way for writing in the exam to explain everything. But if you want to do something quickly, so what we do here, I don't know, by experience, I start multiplying them. Okay, so the right hand side, so you see I have two pairs of brackets there. I want to multiply them. Just help me to do that. What happens? I keep the denominator. Yes, if you want to do it quickly. Then I have to take 1 and multiply it in this one. So it becomes what? Tangent beta minus sine beta. And then I multiply cosine in.
Yes.
Yes?
So it's
Cosine times tangent, I do it in my head. Cosine times tangent is sin. So it becomes plus what? Sin beta. Yes? And then I multiply cosine by that, it becomes negative cosine beta sin beta. Agree or not? I just multiplied it. Then suddenly I get rid of that. Yes? And then the same story, I want this tangent is a partial fraction. It is sine over cosine. So I decide to multiply by cosine. When I multiply by cosine, this becomes sin beta. Yes? This becomes minus cosine squared beta sin beta. But when I multiply the numerator by cosine, I have to multiply the denominator by cosine as well. Understandable? I pull a sine out, it becomes 1 minus cosine, which is sine squared. And then I have this in the denominator. And that's exactly what you got here. So that trying to do these things a little bit fast will teach you something, okay? It's not just because if you want to do something fast, then you need to be more creative. But of course, in the exam, if you write this, or a little bit of explanation, I accept that. But this I cannot refuse because everything is on the board and clear, okay? Is that understandable? But I want you to learn these alternative ways of doing things. This make you faster, okay? But the people, so for example, if you want to be good, you need to be able to evaluate this solution. Okay? So everyone understand that? So is that completely transparent, step by step done? And what is this is actually is expected from you in the exam. Okay, thank you very much. It was very, very good. Okay, number 7. Any volunteers?
Wait.
No volunteers? Do you want to think more? Okay, I can pause the video recording again. So in number 7 might be this is a good idea to simplify the left hand side and keep it in a box, and then go to the right hand side, simplify the right hand side and keep it in a box, and then compare the results. The boxes should be the same. I don't like these methods. I don't know. This is coming from perfectionism. I just want to start from one side to go to the other side, but you don't have to. Yes? You can simplify the left hand side, you can simplify the right hand side and then compare them, okay? Yes? But if you want to impress me in the exam, do not do this, okay? That's up to you. I'm just kidding. But I'm just telling you that why this is, by the way, why this is correct, because I am supposed to show A is equal to B. If I can show that A is equal to C, and if I can show simultaneously that B is also equal to C, then the logical consequence would be that A is equal to B. So I cannot fight with that. That's completely logical. Yes, completely logical. Yes, do you have questions? No, okay, you can sit down if you want to. Okay, so this is the logic. Okay, now I don't know which one is easier because I see on the left hand side I have a combination of cosine and sine. On the right hand side I have a combination of tangent. Might be this is easier for you. Yes?
I solved it, but like you said,
Yeah, do you want to come here?
Yes.
Yes? Yeah, please. I think the whiteboard is easier. Yes, if you use it here, this is up, you can see, everyone can see. I can raise it up. Yes. Yeah, please do that. Yeah, I think cleaning that one is easier. So you want to start from the left hand side and then the right hand side and then compare, yes?
Okay.
Yes.
So first I wrote with the first bracket.
Yes?
I kept 1 over
No,
sine.
please write left hand side is equal to. This I am sensitive to, yes? Because, yeah. Because in the exam I shouldn't get confused, you know?
Okay, left hand side. I kept
Equals to.
equals to.
Yeah, now you can start.
Yeah, okay. So 1 over sine x
Yes.
minus. Now I change sine x to sine x squared
Yes.
over sine
Yes.
because
very
I
good.
want
The denominators to be the same.
yes, the denominators. Brackets, and I do the same with other brackets. So 1 over cosine x minus, so this, if you multiply, then
Yes.
it's gonna be cosine x squared over cosine x, brackets close. Then we can write this under the same denominator, and
Yes.
1 minus sine 2x over sine x. Same here. 1 minus cosine over cos x.
Yes.
Now we can see that
This famous combination.
this is a famous combination, and this is equal to cosine x squared.
Yes.
So cosine.
By the way, Nabila actually reads it correct. I read it wrong. I say cosine squared x. This is wrong. Cosine x squared is correct.
And 1
Yes.
minus, same here, this is also the famous combination, but this is equal to sine x squared.
Yes.
Now I can see that if you only have cosine x over sine x,
Yes.
this is equal to 1 over tangent.
Yes. And is that understandable for everyone? Yes.
So I can write this as 1 over tangent x, and you have 1 cosine left, so times cosine x.
Yes.
And here we know that sine divided by cosine is tangent, but we have 1 sine left.
Yes.
So we got tangent times sine x. Where should I continue in?
No, you can clean here, whatever you are. Now you are the teacher.
Okay.
I don't ask you where should I write.
Okay, so then we can we can just multiply everything.
Yes.
And we got cosine, I did it like this, cosine times tangent times sine x. Okay, so these
Yes.
cancel each other, so we get cosine x times sine x, and this was the right, no, this was the left hand side.
So put this in a box. Yes. So what she calculated for the left hand side. Yes, this is what she got for the left hand side. Okay, let us go to the right hand side.
Right hand side. And the right hand, we have it on the board there, so it's tangent x plus over 1 plus tangent x squared.
Yes.
And this is a combination,
Yes.
and it is equal to 1 over cosine squared.
Yes. Can you raise the board a little bit? Yes. Yes. So you have it in your memory. If you want, you can use it. Yes. 1 plus tangent squared.
So we can write it like this just to show that this
Yes.
tangent x, this is the same,
Yes.
and it is equal to 1 over cosine x squared.
Yes.
And you can write this as tangent x times cosine squared, x squared.
Yes.
And you can write tangent x as sine, no, what is it?
Yes. Yes.
Yes,
Sine X.
sine x divided by cosine x. this was only the tangent part, and we got cosine x squared left, and one of these cancel each other, so we are left with sine x times cosine x.
Which is also the right hand side, and then you can compare these two, they are the same.
So,
Yes, thank you very much. By the way, you are a very good teacher. Yes. Okay, so let me try to see what I can say. First of all, you made a lot of trouble for yourself. I want you to get experienced now. Okay, so I don't have any objections so far. Everything is good. So where this tangent is gone? Okay, so you wrote something. Okay, this is not in the solution, by the way. Don't get it. This is explanation. Okay, and this I want you to learn this now. You made a lot of trouble by taking these things with you. Okay, so this is a fraction. 2 over 5, and then I multiply it by 4. Here is 10. I can simplify this with that as well. You don't need to carry them with you. Here you could manage it and you get the full mark, no problems. But if the problem is slightly harder and you want to carry everything with you, then you will be tired in the middle, okay? So if I want to solve this, I would take one cosine from here, and one of these cosines are gone. So just cosine is left. You will see, and this one and that one are gone. Sin cosine is exactly the answer. So you can just finish it just here, you see? Yes? But this one you actually did great, because you just used the formula. Everybody understands why cosine goes up, because if I have a over 1 over b, everyone hopefully agrees that this is ab. Yes or no?
Yes.
Yes? So this is the reason that this goes up, and then everything you have done is correct. So it means that you know this rule, because you use the rule here, but you didn't use the same rule there. Yes? But that is completely correct. So we learned this one as well. So you see, we have some examples. We started from the left-hand side to the right, from right-hand side to the left, and then simplify the left, simplify the right, and compare. So these are the only ones, yes? But then you have to practice. I think there is a very nice one from an American teacher. I found this PDF file. I will upload it for you there. It contains a lot of these problems. Of course, not hard, very hard ones. I have already uploaded hard ones, I think. I will make harder ones for you then. But the good point about that PDF, it contains all the detailed solutions as well. So if you want to practice at the level of the exam, that would be enough. Okay? Any questions? Yeah, thank you very much. Have a nice weekend.
You too.